Keepers 6.3, Riemann sum to an integral. All right, so we have some important formulas. The first one is delta x equals b minus a over n. That's basically telling you the height of each rectangle. So if you're on some interval from a to b, and they tell you how many subintervals you have, you take your intervals, subtract them, so b minus a, and then you divide by n, which is the amount of subintervals you need. That will tell you the length of each subinterval. In other words, it will tell you the height, or sorry, the base of each rectangle. Now this second formula, x sub k equals a plus k delta x, basically tells you the length of like a total amount of rectangles. So like let's say I want the first 3 rectangles. That will tell you, this formula will tell you what the length of the base is for the 3 rectangles. Now the reason why we need to know that is because we need to understand that we can take the Riemann sum, or this summation. I don't know how many of you guys have seen this before, but this big E is your summation notation. You can take your summation of your Riemann sums and you can calculate an integral. The catch is you have to do the limit of it, because I want a billion rectangles. I don't just want 5 subintervals or 10 subintervals. I want an infinite amount of rectangles. In other words, I want rectangles that are so skinny that it almost gives an exact, or it gives an exact approximation or exact answer for the area under the curve. So if you do the limit as n approaches infinity of the sum of all your rectangles, and you find f of whatever rectangle you're on, so that's going to be your height, f of whatever rectangle you're on, times delta x, which is your base, that's giving you the area of a rectangle. And we can approximate that, or we can say that equals the integral from a to b of some function f of x dx. This is the most important formula that you're going to see, or that you're going to need to know for this lesson. All right, so this first example says state the integral the sum is approximating using a right Riemann sum. The first thing I notice is that I have this 1/4, and so this 1/4 is telling me the base of each one of my my rectangles. Now, the next thing I have to understand is that since I'm doing a right Riemann sum, I know that this number over here is going to be the rightmost value, or the furthest right value, or my b value of my interval. And so if I'm cutting them by a fourth, or each one is a fourth, I'm going to count backwards to a fourth. Now again, understanding a right Riemann sum means that you understand that the only thing that we don't include in the right Riemann sum is the leftmost point. So if I'm going from 3 as my rightmost point, and I'm cutting them by a fourth all the way down, I understand that the value that comes right before this sign of 9/4 would be sine of 8/4, which would be 2, which tells me that my integral has to go from 2 to 3, and then my function is sine x dx. All right, so the next example, we're doing pretty much the same thing. I notice that we have the 1/8 out in front, so that tells me that my delta x is 1/8. I also know that they told me I'm doing a right Riemann sum, so that tells me that this 2 over here is my furthest right point, or my b value of my interval. And I know that I have a total of 8 subintervals. And I can see that simply by counting 1, 2, 3 all the way down. I can count how many pieces I have in here to see that I have 8 subintervals. So again, because I'm doing a right Riemann sum, I understand that this leftmost value, whatever comes before the very first one, this leftmost value is not included, because that would be included in the left Riemann sum. So I need to figure out what this left value is. So if I simply take this 1 1/8 and subtract off my delta x, or subtract off 1/8, I know that this left value had to have been 1, which tells me my integral went from 1 to 2, and then clearly I can see that this function is 1 over something squared, or 1 over x squared, and then dx. All right, so the next one is a left Riemann sum. And again, I notice that 1/4 is in front, so I know my delta x is 1/4. Left Riemann sum. And then I know also that I have 4 subintervals, because I have 4 pieces inside of my bracket. Now with the left Riemann sum, I understand that this 1 here is going to be the it's going to be the leftmost value, or my A value. And I understand also that with the left Riemann sum, the rightmost value, whatever comes out here, is not actually being calculated. So if I take this 1.75 and I add my delta x, or if I add 0.25 to it, I understand that this rightmost value would have been 2, or my b value would have been 2. So my integral is going to go from 1 to 2 of 1 over 2x dx. Alright, so the next thing is a little bit different. They want us to find the integral representation of the summation. And it's different because they didn't actually write the summation out for us. They're giving us in like a condensed summation form. So we have the limit as n approaches infinity, which tells me that I'm integrating because I'm getting all my little rectangles and I'm adding them all up. Of 1 over n summation from j to 1, j equals 1 to n, j over n to the fourth. Alright, so when you do this, basically you want to think about your actual summation formula that I told you was important at the beginning of this lesson. And so we have that formula, and we understand that that formula basically is telling us what to look for. So if we match it up, I notice that this piece in the middle, this a plus j delta x, is simply this piece inside the function because it's f of something, and I know j over n is being raised to the fourth, so I know that this a plus j delta x is simply 0 plus j over n. It's whatever's inside of your function. Alright, so that tells me that a is 0, my delta x is 1 over n, and my function itself has to be x to the fourth. And you can pretty much look at it a lot of times and see what your function is going to be. Because I have that j over n, or that a plus j delta x raised to the fourth, I know it's going to be x to the fourth. Alright, so pretty much all I did there was kind of match it up to what my summation notation should look like to pull out some of my variables. Alright, so that tells me that, again, using that original formula, that integral a to b f of x dx must be the integral from 0 to b x to the fourth dx, which means the only thing I have to find is my b value. Alright, so to find my b value, I'm going to use my formula for delta x. And I know that delta x is b minus a over n, but we know that a is 0, so that's b minus 0 over n. And I know the delta x in this formula was 1 over n, so b minus 0 over n has to be 1 over n, which means that b minus 0 has to equal 1, or b equals 1. And so now I can write my final integral as 0 to 1 x to the fourth dx. Alright, so next example, pretty much the same exact thing. I want to take my original equation, my original formula, and kind of match it up to what they gave me. So again, here's my original formula, my summation part of it. And I know that this a plus j, this inside piece right here, has to equal this inside piece right here. Those two things have to equal. So a plus j delta x has to equal 2 plus 3j over n, which tells me that a must be 2, delta x must be 3 over n, and that means my function f of x is x to the fourth again. Now, plugging that into my integral part of my formula, I have integral from a to b f of x dx. I know a is 2, so I have the integral from 2 to b f of x is x to the fourth dx. Alright, so again, all I have to do is find out my b value. So I'm going to use my delta x formula. I know delta x equals b minus a over n, but a is 2, so b minus 2 over n. And I know that delta x from earlier, we figured out that delta x had to be 3 over n. So now I can set up an equation. I can say b minus 2 has to equal 3. In other words, b has to be 5. So writing my final integral, I get the integral from 2 to 5, x to the fourth dx. Alright, let's try one more example to make sure that we really have it. So again, I'm going to start with my summation formula. And what I need to recognize is this a plus j delta x has to be this piece right here, negative 2 plus 5j over n. And so once I realize that, I can tell that my a had to be negative 2, my delta x had to be 5 over n, and my f of x clearly looks like e to the x. Alright, so now plugging that into my integral part of the formula, I get the integral from negative 2 to b e to the x dx. Now using delta x, I get b minus a over n is b plus 2 over n. And I know that my delta x from earlier, we said delta x was 5 over n, so I can set that equal to 5 over n. Now, solving this out, I get b plus 2 equals 5. I subtract 2 on both sides, and I get b equals 3. So that means my final integral is the integral from -2 to 3, e to the x dx.